Hi guys, you welcome to my channel. So today we are going to commence the JAMB series like I promised in my last video. And the first question we are going to be looking at today is the second question of JAMB 2010. Why am I starting with JAMB 2010? I've taken my time to study that particular year and it covers a lot of topic in physics syllabus. That's why we are starting with it. But I want you to pay maximum attention to the method that I will be using to take you through this 2023 JAMB tutorial. You have to pay attention very well because it's one of the most effective methods that I've been using to prepare students for JAMB in 3 days. Yeah, for the past 5 years, I've been organizing 3 days to JAMB class and it has always been effective. And I have a very good record of students who have actually made their JAMB through that particular class. So if I can do that in 3 days, I believe doing this for like 2 months now before you write your JAMB is going to go a long way. So please pay maximum attention. If you are yet to subscribe to this channel, don't forget to do that now. And if you have subscribed before, just like this video, comment and share within your friends. So without wasting much of our time, let's get started. And let me just quickly describe how the class is going to go for you. We are going to get a past question. You can check the description box. I have the link to download the 4 past questions. JAMB, for JAMB rather, English, mathematics, English, mathematics, chemistry, and biology. That is the whole of the subject combination for science students. You can download it there. Just check the description box to download the past question. Pick that of the physics, open to 2010, question number 2. Now, what are we going to be doing? We are going to read out the question and we are going to identify the topic that the question belongs to. Then, I'm going to treat the topic in line with JAMB syllabus. That is the focus of JAMB on that topic. I'm going to pinpoint how to answer every question that has to do with that question, such that you know you are good to go with that particular topic. Is that taken now? Then we move to the next question, which is going to be question number 3 like that. We read the question and we pick what? The topic, treat the topic in line with JAMB syllabus, and you'll be able to answer any question on such topic. That is how we are going to do till we finish the whole of the question in that particular year, and we move to the next year to also do what? Do the same thing. And I'm telling you before you get to know, we are going to finish the whole of the JAMB syllabus and you will be able to treat the whole of the past question. I have a good news for you guys. I'm going to share that with you at the end of the video, so kindly stay tuned. It's very important you listen to that. So let's get started now. So the question, as you can see on the screen right now, the question states that 2 cars moving in the same direction have speeds of 100 km per hour and 130 km per hour. What is the velocity of the faster car as measured by an observer in the slower car? A. 130 km per hour, B. 230 km per hour, C. 200 km per hour, and D. 30 km per hour. Now, if you look at this question, because the first thing that tells if you'll be able to answer a question is ability to identify the topic. Anything that makes you not to be able to identify the topic, then answering that question is going to be on guess. Is that taken out? So this topic is under relative velocity. So we are going to look at relative velocity in detail so that when you handle any JAMB question under this particular topic, you are good to go. Are you getting that now? So let's get started. Now the question is, what comes to your mind when you hear the word relative velocity? As for me, what comes to my mind when they say relative velocity is what? The difference in velocity of observer and the reference frame. You know, when I say observer and reference frame, you are saying the same thing. I intend to say the difference between the velocity of the reference frame and the observed object. Is that taken out? That is the focused object and the reference frame. The difference between their velocity is what we refer to as relative velocity. Okay, let's get into it. So when you say relative velocity of an object is going to be what? V1 minus V2. Now, what is V1? What is V2? Let me make it more clearer. Now, let's take for instance that I have a velocity V sub AB. This is equal to velocity A minus velocity B. What does this simply mean? Try to understand this very well. If you understand this very well, then you already understand the concept of relative velocity. Now, I'll take it again so that you understand. When they say relative velocity, they are saying the difference between velocities. Difference between velocity of what? Difference between velocity of an object and its reference frame. Are you getting this now? Difference between the velocity of an object and its reference frame. So let's look up now. If I have velocity AB, what this simply means is that I'm looking for the velocity of A in relative with that of B. Are you there now? Velocity of A in relative what? In respect, let me put it like that, in respect to that of B. Velocity of A in respect to that of B. That is what this one simply means. So what do I mean by velocity of A in respect to that of B? What I mean is that the focused object is A. The reference frame is what? B. Now, for those of us that we are yet to understand what they call reference frame, I'm going to break it down and you are going to understand, but let's move on first. So, this is the object. The object is A and the reference frame is what? B. So, if I'm looking for the relative velocity between A and B, I'm going to have this to be what? VA minus VB. So, if I'm looking for the relative velocity of BA, now, what I mean now is that the focused object is B. So, focused object is what? B. And the reference frame is A. So, that will become what? Velocity of B minus velocity of A. Do you understand that now? Are we getting this now? Correct. So, if I now say velocity of, let's say, velocity of C, let's say CD, velocity CD. This means that C is the what? Object, the focused object, and D is the what? Reference frame. So, the relative velocity is going to be what? VC minus VD. And if it is that I'm looking for VDC, that means that D is what? The object, and C is the reference frame. And this equal to VD minus VC. Do you understand that now? Okay, so what is now VD? What is VC? So, VC, or let me start from VA. VA is the velocity of object A in reference to the X. So the X is going to be the relative what? The reference frame for velocity A. While the X is still going to be what? Reference frame for velocity B. Are you getting this now? I know you still don't get it clear, but don't worry. I'm going to break it down and you're going to get what I'm trying to explain now. Just watch. If you look at this, let me break it down like this, so that you will understand clearly. If I have velocity AB, this is velocity A minus velocity B. Are you getting this now? What this simply means is that this is my reference frame. That is an observer. Somebody that is observing A. And this is what they are observing. That is the object that they are observing. So if B is observing what? A. Definitely A is in respect of B. For that reason, B is going to be the reference frame for A. But if I have VA, if it is happening inside the X, then the reference frame for VA is going to be the X. VB, the reference frame for VB, since it's inside the X, is also going to be what? X. Are you getting this now? So, for that reason, the question I expect you to ask, or what I think you should understand now, is that why are we using X as the reference frame for these ones? We are using X as the reference frame for this and this because the Earth is moving with a constant speed. And when an object is moving with a constant speed, it's assuming the object is at rest. Do you understand that now? It's assumed that what? The object is at rest. So when you see VA, the reference frame is what? The Earth. When you see VB, the reference frame is what? The Earth. But when you see VAB, the reference of A is going to be B. Likewise, if I have VBA, this is equal to VB minus VA. What it simply means is that what? The reference frame of B is A in this case. Are you getting this now? That is, B is the object, the focused object, while A is the reference frame. Then, VB in this case is what? Velocity of object B, whereby the Earth is the reference frame. VA is the velocity of object A, whereby the Earth is the reference frame. Now, let you understand what they call reference frame now, so that you will get everything clearly. Now, when they say reference frame, this is what we mean. Let's take, for instance, that I have a car like this, and this is me inside the car. Let me call this one A. And the car is now moving with velocity of, let's say, 100 kilometers per hour. Are you following? And then I have another object here, another car. This is a car, this is another car. And this is you inside the car. You are inside this car. And this car is moving with velocity of 130 kilometers per hour. So let's call this one B. I want to explain what they call reference frame for you now. Now, if you, that you are inside this car, you want to measure my own speed that I'm inside this car, you become the reference frame. I become the focused object. Do you understand that now? And if it is that me, that I'm inside this car A, I want to measure your own speed that you are inside the car B, then I become the reference frame, you become the focused object. Do you understand that now? I believe you understand the aspect of reference frame clearly now. Now, how do we find relative velocity? When we are looking for relative velocity, there are two things to consider. Two things to consider. What is the first thing? The first thing to consider is the reference frame. Is it one-dimensional or two-dimensional? You need to understand that. The second thing to consider is the direction. Is it towards the positive side or towards the negative side? Are they facing the same side or opposite side? You need to understand that also. Those two things are what you need to do well in answering questions under relative velocity. And we are going to break everything down now so that you are going to understand it for subsequent questions and for this particular question as well. So let's get started. Now, let's take for instance that you are inside what? This object B. You want to measure my speed that I'm inside what? Inside A. How do you do that? We do that by considering first your position. You are going in this direction, I'm also going in that direction. This is towards east, then it is positive. So since it is positive, I go by saying VAB, can you see that now? Is equal to VA minus VB. Why VAB? Because you are the observer. Are you getting this now? I'm the focused object. That's why I'm taking your own velocity away from my own velocity. to get the actual thing that is happening. Is that taken now? So you will always, for anything relative velocity, you are to take the velocity of the observer. That is, this is the object now. You are to take the velocity of the observer from the velocity of the object in order for you to get the results. Do you understand that now? I believe it's clear. Anything relative velocity, velocity of the object minus the velocity of the observer. You have understand the object and you have understand the observer, isn't it? So let's go on. Now, in this case now, the velocity AB, that is the velocity that you are going to measure of my own, is going to be what? 100 minus 130, and that will give us negative 30 kilometer per hour. What's the meaning of this? Why negative 30 kilometer per hour? The reason why you are having negative is because your own speed is higher than my own speed. Why? 30 kilometer per hour. Are you getting where I'm coming from now? That is, for every 1 hour, your speed is greater than my own speed by 30 kilometers. For every 1 hour, your own speed is greater than my own speed by 30 kilometers. So, by knowing your own what? Your own speed, you can tell what my own speed will be as the observer and me as the object. Do you understand that aspect clearly? Let me take it again calmly so that you get it. You are the observer. You are inside this moving car, and your own car is moving with 130 kilometers per hour. And this is me that you are observing. You want to measure my own speed, and I'm moving with 100 kilometers per hour. Me, I become the object. You become the reference frame. And that is why we have VAB. That is what? VA minus VB. Are you getting this now? This is my own velocity in respect to the x. This is your own velocity in respect to the x. Is that taken now? So when you take the difference, you have a negative what? Value. You are having a negative value because what? Your own speed is greater than my own speed by 30 kilometers. So the meaning of this now is that for every 1 hour, you are going to be 30 kilometers ahead of me. That's what it means. Now, you get to see that we started at the same point. So, that 30 kilometers is not something that just happened once. Are you getting it now? It's something that will happen gradually. It's just like two cars, they are beside each other and they start at the same time. And me and you are moving with what? 130, I'm moving with what? 100. Those two cars will be going together. After 1 hour, by the time you are going to measure the distance between their two, it's going to be what? 30 kilometers. Do you understand that now? But because the person that is particular about the speed is what? You, that you are inside the what? 130 kilometers. That's why the answer is what? Negative. Now, let us now say that it is me that I want to observe you. That is, the observer in A want to measure the speed of the car B. What will be the result? So the result is going to become VBA, VBA equal VB minus VA. So in this case now, B has become the focused object and A has become what? The reference frame. Since the observer is me now, not you anymore. So what are we going to get now? VB is what? 130. Minus VA is what? 100. So we have what? Positive 30 kilometers per hour. So what's the meaning of this? What it simply means is that your speed is greater than my own speed by 30 kilometers. That simply means that for every 1 hour, your speed will always be ahead of my own by 30 kilometers. Just like my own will always be beyond your own speed by 30 kilometers. I believe it's clear now. Alright, let's see another example. Now, another example I would like to show us right now is, let's take for instance that this is you here, and your speed is about, let's say, 50 kilometers per hour. Let's call this A. And this is me, and I'm moving towards this direction. I'm moving towards this direction, and my speed is, let's say, 60 kilometers per hour. Now, I want you to look at something right here now. You see now that what we are dealing with now, it is what? Opposite in direction. The first case is what? In the same direction. The second case now is what? Opposite direction. So this is how you can have it in JAMB. Is that you have the same direction, or you have what? Opposite direction. So this is case 2 now. So if you are the observer, that is, you are the B, and then you want to measure my speed. You know, I'm the A, you are the B. You are the observer now, I'm the object. So the relative velocity is going to become velocity AB equal VA minus VB. Do you grab that now? Because I'm the object and you are the observer. You are the one that want to measure my own speed now. But we are moving in opposite direction. Now, you will see what this will become. VA is what? 50 minus 60. Now the question now is, why minus? It is minus because you are moving towards the negative axis. That is, you are moving towards the west. I am moving in positive axis. I'm moving towards the east. That's why this one is attracting negative. Is that taken now? So, if that should be the case now, this result is going to become 50 plus 60, and that is 110 kilometers per hour. Do you understand that now? 110 kilometers per hour. Now, what's the meaning of this 110 kilometers per hour? Alright, let me break it down so that it's going to be meaningful now. What this one simply means is that at every 1 hour, at every 1 hour, the distance between myself and you, are you getting this now? That is, I'm going to get closer to you by 110 kilometers in every 1 hour. That is what it means. Do you understand that now? This 110 kilometers per hour means I'm going to get closer to you by 110 kilometers every hour. For you to understand, let's say this is this object here, and this object, and this is you. This is me here, and this is you. And the distance between us, let's say it is okay, let's say between myself and you, let's just pick a value of, okay, let's say 200 kilometers. That's the distance between myself and you now. And I'm moving towards you by velocity of 50 kilometers per hour. And you are moving towards me by velocity of 60 kilometers per hour. Are you seeing this now? So if I have 50 plus 60, I'm going to have what? I'm going to have 110. Are you getting it now? So it means that by the time you take your 50 away from this and you take your 60 away from this, the distance between us will reduce to what? 110 kilometers per hour. Do you understand that now? So that's why I said I'm approaching you by what? 110 kilometers per hour. So because by the time you take away what you have, are you seeing this now? And this, we have what? 110 kilometers. Do you understand that now? So that is how we calculate when the objects are facing the same direction. So it's just pretty much this. 50 plus 60, you have what? You have 110. If you take away 110 from 200, you are going to have what? 90 kilometers. So by moving closer to you with a distance of what? 110 kilometers is reducing what? The distance that is between us by 90 kilometers. Do you understand that now? So I'm approaching you by what? A speed of 110 kilometers every hour. Do you get that now? So the distance between us reduced to what? To 90 kilometers instead of the 200 kilometers. I believe you get that aspect clear now. So that is how to deal with relative velocity when facing opposite direction. Now, this has shown that I'm the one approaching you now. Now, let's now take for instance that I'm the observer. You are the object. So, being the observer and you are the object, what does that simply mean? What it means is this. The reverse will be the case now. I'll be having VBA. So, you have become the object, I have become the observer. So, that will become VB minus VA. So, what would that be? This one will be what? Negative 60 minus 60 kilometers per hour. Let me remove this. Minus 60 minus what? Minus 50. That will give us what? Negative 110 kilometers. So, negative 110 kilometers, what it simply means? What it means is that you are approaching me by a speed of what? 10 kilometers. That is, you are getting closer to me by 110 kilometers every 1 hour. That's why the negative is there. The negative is telling you that you are the one approaching me now, not me approaching you, because I'm not the observer. When you are the observer, I'm the one approaching you. That's why you get what? Positive. When I'm the observer now, you are the one approaching me. That's why what? It becomes negative. I believe you understand that now. Okay? So now let's take another scenario. Another scenario for you to be able to handle any question under this is, should in case I have something like this. This is me inside my own car, and this is you inside your own car. I'm moving like this with a speed of, let's say, a speed of, let's still retain our 60 kilometers per hour. Are you there now? And then you are moving with a speed of, let's say, okay, let me pick 100 kilometers per hour. Just watch what will happen. I now throw a ball. I throw what? A ball. And the velocity of the ball in respect to the car. This is A, this is B. Let's say the ball velocity now is C. Let's say it is 20 kilometers per hour. The question now states that find the velocity of what? Of this ball as measured by you, which you are the observer now. You are the observer in this car now. The question now says find the velocity of what? Of this ball as measured by you. That simply means you are looking for what? VCB. And that will be what? Velocity C minus velocity B. Do you understand that now? So because it is this velocity of this ball that they ask you to look for. But don't forget that this velocity that you have here, which is 20 kilometers per hour, it is the what? Relative velocity with this car. That is, the reference frame is this car. Do you understand that now? Why this 60 kilometers is the reference frame, or is the velocity of this car whose reference frame is the earth. Just like 100 kilometers per hour is the velocity of you, and your reference frame is what? Earth. But for the ball, 20 kilometers per hour, the reference frame is what? The car. So VC is going to be what? Velocity of this ball in reference to the earth, minus velocity of you in reference to the earth. So for us to be able to solve this question, don't make the mistake of using this 20 here. Do you understand that now? So we need to find the what? The velocity of this ball in relative with what? With the earth. Is that taken now? So how do we do that? We say the velocity AC is going to be velocity A minus what? Velocity C. Do you understand that now? Okay, so if that should be the case now, we are going to be having that the velocity AC, which is what? 20. So we have 20 equal velocity A, which is what? 60, minus velocity of this one in respect to the earth. We don't know it. So we have what? VC to equal to 60 minus 20, and that gives us what? 4 km per hour. So we have gotten what? The velocity of this ball in respect to the earth to be 40 km per hour. So with that, we can now get what? The relative velocity of this ball in reference to U. How do we go about that? We just say VCB is equals to what? 40 minus what? VB, which is 100. So VCB equal negative 60 km per hour. So what does that mean? This simply means that this object is moving faster. Are you getting this now? Such that for every 1 hour is 60 km ahead of the ball. Do you understand that now? It's moving faster such that what? It is 60 km ahead of the ball. So that is how to tackle this kind of question. So once you see that an object is having what? Another reference frame other than the earth, before you can use it with the one that has a reference frame with the earth, you must find its own velocity in reference to the earth. Am I clear now? So the last part of reference frame that you need to be careful of is two-dimensional. If you have it to be two-dimensional, what do I mean by two-dimensional? Let's take for instance that I'm in a car, and this is you are static this time around. And you are looking at me inside the car. This is me inside the car. This car is moving forward with a velocity of, let's say, 3 km per hour. It's moving towards the east. And this is me inside the car. I'm inside the car and I'm moving towards the north with a velocity of 4 km per hour. Are you getting where I'm coming from now? So, remember, I'm inside this car. And the car is moving towards east. Me, I'm moving towards what? The north. This observer, what is he going to measure of my speed? So, you now, you want to measure my speed. Take it clear now. You are static. You are just standing here. Looking at me inside the car. The car is moving towards what? East. And I'm inside the car moving towards north. Are you following now? And you want to measure my speed. What will be the value? So what you are looking for is what? The relative velocity. And for you to be able to get that, you just have to look for the resultant speed between myself and the car. So once you're able to get the resultant speed between myself and the car, that would be what? The relative velocity. Am I clear now? So how do we do that? So we just come down here. So this will be what? The resultant speed. So let's call this VAB. Are you getting this now? And this is what? 90 degrees. So VAB is equal to 3 km per... Okay, let me just remove the unit. 3 square plus 4 square. Pythagoras theorem. So VAB becomes 9 plus 16. And that will give us 25. This is square. So VAB equal the square root of 25. And that will become what? 5 km per hour. So my speed that you are going to measure is going to be what? 5 km per hour. Do you understand that now? So that is how to deal with questions under reference frame. So that is how your question is set to come. So right now, with all this explanation now, I believe now you can now attempt this particular question. So kindly drop your answer in the comment section and let me know what you have chosen to be the right answer. Is it A, B, or C, or D? Let us know in the comment section. And the good news I have for you is that if you look at beside the subscriber, you are going to see a button there right now. That button called join. That is the button to join this the member of this channel, where you are going to be what? Exposed to exclusive content. To know more about this membership, you can check the description for intro video on the membership. For example now, this particular topic now, the whole of the questions that JAMB has set on this topic is available. The solution is available for every member of this channel. So when I say member of this channel, I'm not talking about the subscribers only. I'm talking about those who have chosen to be part of the premium member of this channel. So read more and listen more about what the member of the team through the description box. And as always, see you guys tomorrow with the question number 3 that will take us to another topic. Good day.